It seems like homemade tunnels are kinda having a moment. Just about everywhere I look, it feels like someone is carving new spaces from the ground and documenting the process online. Colin Furze might be the quintessential example with his wild tunnel project connecting his shop and house to an underground garage. You can watch the entire process in a series of videos on his YouTube channel, and he even started a second channel to share more details of the build. But he's far from the only one. TikTok creator Kala, lovingly nicknamed Tunnel Girl, has been sharing the almost entirely solo excavation of a tunnel system below her house, amassing more than 1 million followers in the process. Zach from the Jerry Rig Everything channel has an ongoing series about a massive underground bunker project, not strictly a tunnel, but in the same spirit. In Wisconsin, Eric Sutherland and a team of volunteers have built Sandland, which features a maze of sandstone tunnels in the hillside that can occasionally be seen on the Save It for Parts channel. My friend Brent bought the abandoned mining town of Cerro Gordo and regularly explores the shafts and drifts on his channel, Ghost Town Living. And there are lots more. Wikipedia has a whole page about hobby tunneling, which it defines as tunnel construction as a pastime. There's something captivating about subterranean construction, delving into the deep, carving habitable space from the earth. In one case in Toronto, a tunnel was discovered in a public park, sparking headlines worldwide and fueling wild conspiracy theories about terrorist plots. Turns out, it was just a guy who liked digging. When he was interviewed by Maclean's, he said, quote, "Honestly, I loved it so much, I don't know why I loved it. It was something so cool." What more can you say than that? Some of us just yearn for the mines. Plenty of people have front yards and backyards, but not everyone has an underyard. But the thing is, underground construction is pretty dangerous, and not only that, it also poses a lot of very unique engineering challenges that a hobbyist might not be prepared to solve. So I thought it might be fun to do a little exploration into modern tunnel construction methods used in public infrastructure and how those lessons can be applied to endeavors of the more homemade variety. Don't take it as advice. I am a civil engineer, but I'm not your civil engineer. That said, maybe I can at least give you a sense of what's involved in a project like this, and some things that you might want to study further before you get out the pickaxe and helmet light. I'm Grady, and this is Practical Engineering. I think one of the reasons that tunneling is so awesome is that the underground seems kind of like a no man's land. It's a different kind of wilderness, unexplored territory in a world where everything else already feels explored. But it's not really true. Land ownership is a tricky subject, but in most places, when you own land, you don't just own the surface, but everything below it as well. There are obvious practical limitations to that. Some places separate mineral rights, and there's plenty of legal nuance too, but in effect, it means that trespassing is still a thing below the ground. Land ownership is 3D. Major tunnel projects, whether for transportation or utilities, are preceded by the acquisition of rights, typically in the form of subsurface easements. In some cases, it can be a pretty nice deal for a landowner, getting paid just for a subway or highway, sewer pipe, or fiber optic line that can run deep below your property without you even noticing. So that's the first rule of hobby tunneling: only do it where you're allowed to. There's an old internet legend about a plumber in Ireland who dug a tunnel from his house to the local pub. It started as a satirical news article that a lot of people believed, but I think the reason it spread is that it taps into a comforting fantasy that if you go deep enough, the rules stop applying. Unfortunately, they don't. Even a tunnel that never breaks the surface can still constitute trespassing, and nobody noticed isn't a permit. Speaking of permits, just like any other part of the built environment, there are often regulations around where and how you can construct a tunnel. I'm talking about building codes. They can feel frustrating to someone who just wants the freedom to build what they want on their own property. The thing is, codes aren't really there to protect you from yourself, they're to protect the safety and well-being of everyone else. They're kind of society's way of recognizing that the built world is more stable than the people who make use of it. A tunnel is likely to outlast the person who designed and built it, so authorities often want a say in how it's made. This is a very broad statement, but I think it's fair to say that we generally enjoy an expectation of safety when we interact with the built environment. The main reason for that is codes. They're how we bake lessons from past tragedies into the next generation of construction. Codes are often written in blood, as the saying goes, so that's lesson number 2, get a permit. Even if you live in an area with no building codes, if you have a loan, and especially if you have an insurance policy, there's a good chance that your lender or insurer is going to have something to say about a hobby tunnel. No one likes red tape, but digging deep means the stakes are high enough that some amount of prudence makes sense. Of course, if you do dig in a place with building codes, those codes probably aren't going to give you specific design criteria for a tunnel project. Instead, for unusual projects with high consequences of failure, they'll tell you something pretty simple: you need to hire an engineer. There's just too much that can go wrong for any building authority to trust an unqualified hobbyist to get the details right. And I want to show you just a few of the things that an engineer is going to consider in the process. First and foremost is the ground itself. Not all tunnels are created equal because geology varies across the world, and nearly every part of a subsurface project is affected by geology. You don't choose the design parameters, the ground does. Take, for example, the excavation process itself. Look at the vast array of mining and tunneling equipment to get a sense of how conditions dictate the methods and tools. Maybe you have soft sandy soil that's easy to dislodge with a shovel or pickaxe. Firm clays or softer rock might require power tools like a hydraulic arm or hammer drill. Hard and competent rock steps up the challenge where larger rock milling or grinding equipment or even blasting with explosives is the only way to make progress. The tools you need to excavate depend entirely on what kind of rock or soil you have to work with, but that's not all it affects. In general, the ease of excavation is inversely correlated with stability. The more readily soil or rock particles come free from each other when you're digging, the more likely they are to do it when you don't want them to. I've talked about excavation safety in some previous videos. The gist of it is that soil and rock don't love tension. Anytime you cut a steep or vertical slope, it changes the forces between the particles, whether they're tiny grains, cobbles, boulders, or slabs. Soil particles are strong against each other, but they don't hold on so much if they're pulled apart. Trench collapses are one of the most common causes of construction fatalities. Modern projects go to great lengths and expense to stabilize excavations, like trenches and holes. Temporary shoring supports the walls of excavation so they're safe to work inside. And what's a trench if not a topless tunnel? But adding that top makes things more complicated. For one, you have a roof of earth above you. Talk about tension in soil and rock, trying to use them as a ceiling is basically the most unstable loading condition you can have. For two, we have to talk about the idea of earth pressure. Just like the water pressure goes up as you swim downward, the earth does a similar thing. The deeper you go, the more stress the materials are under from the weight of the soil and rock above. Of course, earth and materials don't act exactly like fluids. They can arch and shift load paths around an opening, but it's extremely material dependent. For most types of soil, you basically need support as soon as you excavate, particularly for the roof. Usually that means using a shield. This is a hollow box or tube that advances with the tunnel, providing temporary support for the walls and roof while leaving the face open for excavation. As you cut and remove the soil, the shield moves forward to support the newly excavated area. These have been used since the early days of tunneling, and even modern tunnel boring machines in soft soils use a shield for temporary support until a permanent lining is installed. For rocky tunnels, engineers often use the concept of stand-up time for gauging safety and the urgency of getting supports in place. This is very empirical. It's based less on the physics of the situation than on simple observations over a long period of time. The idea is that if you can measure a few important properties of the rock mass you're tunneling through, like strength and spacing of joints, you can get a rough idea of how long an unsupported excavation will remain stable. This chart shows that relationship between the roof span, the rock mass rating, and the stand-up time. You can see there's a zone of immediate collapse where the span is too big or the rock mass is too unstable. And there's a zone where no support is needed for small spans and competent rock. In between, there's a time limit for how long you have to install supports, and that limit can vary from hours all the way to years. Beyond temporary supports used during excavation, most modern tunnels rely on some kind of permanent support. This is important not only to protect the people and stuff inside from a collapse, but also for the stability of anything above. When a tunnel collapses, that movement can translate all the way to the surface, leading to settlements, sinkholes, and damage to buildings and infrastructure above, especially when the tunnels are shallow. I have a whole video on that topic you can check out after this. Major tunneling projects have extensive monitoring plans to check for movements and adjust construction accordingly. That might mean instruments like extensometers and inclinometers, high-precision survey equipment, and vibration sensors. For a hobby tunnel, especially if you're building below a structure like your house, monitoring for movement is a smart move, even if it's just a well-placed benchmark and cheap laser level. Otherwise, your instruments become doors that won't close and foundation cracks that weren't there before. Like temporary supports during construction, permanent tunnel supports vary a lot. For fairly competent rock with only some joints and fractures, where the instability is dominated by discrete blocks and wedges, supports can be as simple as rock bolts. These anchors are used to stitch the rock together, and they work surprisingly well. I have a video on that topic too, where I used model rock bolts to create a table of gravel. For tunnels where the risk of collapse is greater, many use concrete for permanent lining. The big projects that use tunnel boring machines often have an entire system that can take precast concrete segments and assemble them almost like Lego on the backside of the machine. Then the annular space between the tunnel walls and lining segments is often pressure grouted, so you can get a consistent transfer of ground pressure into the tunnel lining. You can use traditional cast-in-place concrete for lining too. It's easy to get good contact with vertical walls because the concrete can be cast right up against them. But it's a lot harder to place concrete for a roof section that makes good contact without leaving voids. Instead of that, many tunnels rely on pneumatically placed concrete, sometimes known as shotcrete or gunite. That gives you the benefit of not needing forms, but much like using a tunnel boring machine, shotcrete does require specialized machinery and concrete mix designs that aren't super accessible to a hobbyist. Of course, even if the walls of your tunnel are supported after excavation, you still have the challenge of spoils. This is a little silly to say out loud, but this is one of the most difficult parts of tunneling. When you build something on the surface of the earth, the stuff that was there already, namely the air, essentially gets out of the way on its own. With a tunnel, you have to do that work yourself. Do a little mental math exercise with me. Multiply the length of the room you're in right now by its width and its height. Then multiply that number by the average unit weight of soil. If you don't know it by heart, I'll put it on screen now in a few unit systems. Was your answer more than 50 tons? Either metric or imperial? They're close enough that it doesn't really matter here. If you are in anything other than a small closet right now, it definitely was. And I don't know the last time you moved 50 tons of something, but that is an enormous endeavor on its own, especially because most hobby tunnels don't have the space or budget for heavy equipment that's normally used for earth-moving projects. And not only do you have to get it out, you also have to get rid of it somehow, unless you happen to have the land to keep a stockpile nearby. At least with mining, the muck often contains ore, which is a valuable resource. For hobby tunnels, and indeed nearly all tunneling projects, the spoils from excavation are essentially a waste product and represent one of the most difficult aspects of the entire process. In many ways, tunneling is a supply chain problem disguised as digging. Even once you have support, you still have the challenge of water. It doesn't just flow downhill, it also flows down into hills and any other permeable material it can find. Lots of homeowners with old basements understand this challenge. Providing structural support and keeping water out are two distinct jobs for a basement wall or tunnel lining system to do. It's not feasible to make the walls 100% waterproof even in underwater tunnels. Concrete cracks, joints open up. It's basically inevitable that water will get in, so a good design takes that into account. Modern tunnels are equipped with sophisticated drainage systems that collect water, whether it seeps in from the ground or gets in through the portals. Many tunnels even use a sloped profile so that the water can drain out the ends through gravity. If that's not an option, a collection sump and pump is the other way to manage water. Just keep in mind that any materials that struggle in moist environments like wood and unprotected steel may not last long below the ground. Speaking of humidity, air is another challenge in tunnel engineering both during construction and afterwards. In any confined space, you can have higher concentrations of dust and gases that aren't safe to breathe. Work in spaces like this comes with very specific safety rules that include ventilation, gas monitoring, and a standby attendant to maintain communications and call for help if it's needed. Ventilation is important after construction too. Of course, vehicle tunnels have to deal with exhaust fumes, so their design can get pretty complicated. I have a few diagrams in my book, Engineering in Plain Sight, if you want to learn more. But even in a simple hobby tunnel, fresh airflow is critical. Depending on the layout, it can be pretty tricky to get fresh air in and stale air out of the entire space. Ducting and fans are just one more of the complicated systems to juggle. Another reason ventilation is so important in tunnels is the potential for fires. Engineers have to consider where smoke will go and how to keep tunnel occupants safe in the event of a fire inside. Hobby tunnels usually don't have vehicles with combustion engines, but they still carry life safety risks like any habitable structure, so the layout should consider multiple routes for egress and fire suppression. And there are so many of those kinds of details that are, at the very least, worth consideration, if not absolutely necessary for a small-scale personal project. I love the idea of hobby tunnels. There is an aspect of exploration and mystery that you can't really get anywhere else than underground. I don't have a tunneling project of my own, but I definitely live vicariously through the ones I see online, and I hope this video doesn't feel like a wet blanket over any of that. Obviously, the risk profile for an individual hobbyist is going to be a lot different than for a public infrastructure project, so the design, construction methods, and feasibility all look different as well. This is not a how-to video. Again, don't take it as advice, but it's also not me saying, you can't do this. I just think it's interesting to consider the modern solutions to engineering challenges in large-scale tunneling and how those lessons might apply to intrepid hobbyists. Exploring the unknown is kind of a theme with tunneling and what makes it so captivating. I love the idea of being in places that few, if any, have ever been to. My fellow creator, A Bit Frank, normally talks about pop culture on her channel with spooky animations, but she also has a series on exploring curious and odd places. A Bit Obscure has episodes on an abandoned spring, a buried nuclear lab, a hidden sculpture park, and a lot more. I really like these little vignettes, and if you want to check them out, they're only available on Nebula. If you've watched my videos before, you probably know about Nebula, but you may not know about all the original content it has, like A Bit Obscure, Jet Lag, and The Dinner Plan, with some very cool projects coming soon. My videos come out early on Nebula, so you can watch them before everyone else and without any ads. A lot of my favorite channels like Medlife Crisis, Legal Eagle, and City Nerd do the same thing. It's our way of giving you a premium way to watch and funding projects that just wouldn't be possible to do on YouTube. If you want to try it out, now is the perfect time because you can get a full 50% off the regular price if you use the link below, and lifetime subscriptions are 40% off. Pay once and never think about it again. If you're like me, you know that independent creators are the future of great video, so I hope you'll consider subscribing. That's go.nebula.tv/practicalengineering. Thank you for watching, and let me know what you think.